Yeah. Yeah. That's it. So I'm going to keep the 1/2 out here for you and do your brackets. So what do we got there? Antiderivative of 1. X. Sine, close. I think you said sine x. Did you say sine 2x or sine 2x? That's it, right? Plus c. Good. That's it. And then you're going to have to distribute a half through again, right? So we just go and get 1/2 x minus 1/4 sine 2x plus c, box it up. And yeah, did I say 1/4? I wrote 1/2, yeah. That's too easy, right, Garrett? All right, so you want a harder one. I'll give you a harder one then. Garrett has requested a harder one. So how about to the 4th? So how will things change if we put that to the 4th? You can't do it the way I said before. I said if it's odd, you peel a sign, right? If it's even, you want to use that formula. So what here, Garrett, would change? I mean, could I still use this, right? It'd just be the whole thing squared, right? So we're realizing that this is really sine squared x squared dx, right? That's what that is. And so sine squared, we already said, was this, and I'm going to square it. So very important that it's this whole thing squared, including the half. All right, Garrett, I'm going to let you keep going. Well, do you want to move on, Garrett? Okay. All right, so when you square that, Garrett, that's multiplication, right? So when we square things that are multiplied, we square each one, right? Okay, so square me the 1/2 over there. 1/4, let's get it out of the integral. Everyone agree we can do that? And then, Garrett, you have the pleasure of now squaring this, don't you? And there's no way to get around it other than to do your FOIL. Everyone following this? I'm going to give, did you try it out? Are you wanting to go for it? Or?
So it'd be 1 minus cosine 2x minus cosine 2x plus cosine 2x.
Good. And when I write cosine 2x squared, I'm going to put the squared there. Is that all right with you? Everyone agree that that's what would happen if you multiply that times itself? Yeah? Now those middle terms we can collect, can't we? Those two we can put together. So I'll do one more step, I'll collect them, and then we'll just take a look at what we've got there. Plus cosine squared 2x dx. Looking good, looking good. Keep going, Garrett, or you want to pass the baton? You're going to pass it now? Okay, that's fine with me. All right, who is, any volunteers that have not been called on? How about Alexa? Where's Alexa? You're up, Alexa. Are you okay? Okay. All right, Alexa, we have 3 separate terms, right? Can you integrate them one by one here? Yeah, you can split. I mean, you're always allowed, if you have 3 separate ones, you can do them individually, right? So antiderivative of 1, we good with that? X. How about this one? You got to be a little careful with that one. Can you integrate? Like, ignore the negative 2. Just ignore it for now because it's a constant. Can you integrate cosine 2x? 1/2 sine 2x. So the first two, you're in business, right? This one. It's not happening. But guess what it is?
The identity
It's a trig, a sine, or, well, in this case, it's cosine what? Squared. How did we handle sine squared? We switched it using the power reducing formula. Guess what you get to do again? Another power reducing on that. Okay, so I'm going to do this kind of piece by piece. I'm going to kind of help you get to a point again where you can take over. All right, so the first thing you should realize is that I'm actually splitting this up into 3 separate integrals. I forgot a dx right there. I don't like that. Do y'all see what I did? Just distribute the 1/4 through, and I broke it into 3 integrals. So it's 1 times this, dx. It's 1/4 times -2, that's -1/2, and then this, dx. And then the last integral is 1/4 of that, dx. Yeah? Alexa? Alexa already told us that the antiderivative of 1 was x times 1/4, that's 1/4 x. No more integral sign, we're done. And then Alexa said 1/2 sine 2x, but I already had a -1/2 out here, so that's minus 1/4, right? Sine 2x. Plus 1/4. Now, Alexa, you stepped out, so I'm not quite sure you're going to be ready to roll on this. Cosine 2x. What can we do? What can we turn cosine 2x into? That one, right? The 1 plus cosine 2x over 2, but I said I was going to write it a little different. I'm going to write it 1/2 parentheses 1 plus cosine. Now, hold on. Alexa, pay attention for a second on this. The formula, the original formula says this. Cosine squared x equals 1/2 1 plus cosine 2x. The key to the formula is that whatever this is, it gets doubled in the new formula. So if you're going to power reduce cosine squared 2x, it's going to turn into this. This won't be 2x, it'll be 4x. Everyone see that? You're doubling, ooh, that's terrible. You're doubling the angle. If the angle is already 2x, it has to become 4x. That's the proper application of that formula here. Y'all see it? Okay. Do you see why I like this formula more than the other one with the fraction? Do y'all not see why? Why? I'm just going to pop the 1/2 out. Like every single time I use a formula, that 1/2 is always just going to come out. That's why I prefer that formula. So we're at this step now. 1/8 integral, Alexa's taking over, dx. Right, these two are still sitting out here. I'll just bring them down here in a moment. Alexa, can you handle these now? Can you not see it? Antiderivative of 1 would be x. Antiderivative of cosine 4x would be 1/4 sine 4x, right? Everyone got that? So I think I'm ready. I think I'm at the final answer. You have the 1/4 x, and then you have minus 1/4 sine 2x, and then you have plus 1/8 times two different things here. The first one is x, and the second one, Alexa, you said was 1/5, no, 1/4 sine 4x. Close it off. I'm going to have a constant of integration because I'm integrating. Now distribute the 1/8 through. Almost ready to box it. Combine like terms. That's 3/8 x. 1/4 x plus 1/8 x is 3/8 x, and then you put those together and everything else is the same. So that was a pretty big jump in difficulty going from sine squared to sine to the fourth, right? Because we wound up having to use that reduction formula twice. Can you imagine the jump going from sine to the fourth to sine to the sixth? You're going to wind up having to use that reduction or that formula twice in there, and it's a pain in the butt. But I do one of those in my homework solutions. All right, so as far as this section, what I would recommend from 6.2, this is page 326. This will be the last set of problems that would be fair game. Problem 4, 5, 6, 7, 4 through 7, and 10. 10's a monster. It's not a monster because it's hard, it's just a monster because it's long. This is for what? This is 6.2. Yes, this is 6.2. This is not the homework assignment that you'll get when we're done with 6.2. These are only the problems, I've isolated just the problems that use these techniques and would be fair game on the test.
Do you want us to treat them as indefinite?
Always treat them, yes. Yeah, ignore the numbers on the top and bottom of them. What's due on Tuesday? What are we doing on Tuesday? Make sure you bring your homework so I can check you off, give you a quiz grade based on your homework. Come with questions. If you don't come with questions, we will continue this. Have a great weekend. Super Bowl weekend, yay. You get to do calculus and watch football. What better things could you do?